and welcome to your first tutorial ever for running a simulation on pollination using Pollination Grasshopper plugin. In this tutorial, I'm going to show you how to set up a run. I'm going to use a daylight factor recipe. We executed on pollination, and then we visualize the results back inside Rhino. So you should see something like this at the end of the tutorial. Okay, let's get started. So if you don't know what's pollination, pollination is the all-in-one platform for environmental building simulation that we have built. It's built by the same developers as Ladybug Tools team with same concepts, same ideas. You can read more under our blog if you want. I suggest this one, the principles of pollination first, and then you can get started here. But for now, we have three different CAD plugins. One is for Grasshopper, the other one is for Rhino, and the third one is for Revit. The one for Rhino and Revit will be released soon. The one for Grasshopper is already available. You can download the latest version from here. From this page is www.pollination.cloud, and then go under CAD plugins and select Grasshopper. So when you download that, it's just a single-click installer. You just go next, 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 and it installs pollination inside Grasshopper for you. Once it's installed, you should be able to see it here, a new tab for pollination. It comes with a number of components that helps you set up runs, run them on pollination with this component called pollinate, and then check the status, get the results or the inputs, and then check on different jobs and download the outputs. For the Grasshopper plugin, we use a lot of inputs and components that comes with the Ladybug Tools plugin. So don't confuse the two. Like there's a Pollination Grasshopper plugin and Ladybug Tools Grasshopper plugins. So Ladybug Tools Grasshopper plugins are useful to prepare the inputs for the recipes that comes with pollination, and also visualize the outputs that comes with it. For this tutorial, I'm going to use this building, which is the National Renewable Energy Lab building. It's a fairly large model. I'm visualizing here just the edges, but you can see the grid points here too. So yeah, it has a dense grid. It's not too dense, but good enough for a presentation. I think here you should be able. So it's like, yeah, 24,700 almost number of points. And I'm going to set this model up. I mean, the model is set up, set the study up for daylight factor study. We know daylight factor is not the best for assessing the daylight inside your space, but it's an easy one. It doesn't have so many inputs, so I don't have to talk about the recipe much. I can focus on the workflow. So what I have here is a model, is a Honeybee JSON model that I'm going to use for this study. You can, and you watch all the videos for Ladybug Tools, you can create any model that you want. This is just an example. Some people get confused. You don't have to load it from the file. It can be a Grasshopper definition. It can be parametric. I'll record another video for parametric studies. But now that we have a model, we want to run daylight factor study on pollination. How do we do that? So first step, I'm going to bring down this pollinate component, and I'm already logged in. That's not a good thing. So let me log out. And so when you get it, it's actually like this. And actually, I changed my mind. This is not the best component. So I'm going to bring down setup runs component. You see I'm not logged in, so it says login first. To log in, I can double click or right click and says, oh, do you want to be logged in via browser? I'm like, okay. So it goes here, it just logs me in. I was already logged in the web browser. Otherwise, you have to put your username and password, and you'll see the same page. And yep, when you come back here, you know that you're logged in because your username should be here. It should say hello. And that means now I have access to all the projects and all the recipes on pollination. So I double click here again. It pops up a new page for selecting a recipe. And you can see the recipes are under this project, Mustafa demo. They're like annual daylight, custom energy, daylight factor. One is owned by project, the rest are not. So why is it happening is because of this. Because in pollination recipes, unlike Ladybug tools, they are specific to each project. So let me change to another project and you will see. So I'm part of 3 projects on pollination. One is the one under my personal account, Mustafa, and there are 2 under Ladybug tools accounts. I built this one, Emerald Building, exact for this project, so I'm going to select this one. And you see when I select this project, it only has daylight factor available. So I won't have access to other recipes for this project under the organization. And the reason is because this will give you control on setting up the project and setting up the exact recipes that you want to be executed in that project. So make sure like you don't run out of resources because people run recipes that shouldn't be executed on the projects. When you go to your personal accounts, like this one, you have more freedom. There are ones that are not added to the project, but if you select one which is not added to the project and you run it, it will be added to the project. So the Grasshopper plugin basically takes care of that extra step for you to add it to your project for you, so you will be able to execute it. For now, I'm going to use this one under Ladybug Tools, the Emerald Building project. I'm going to select Daylight Factor. So as soon as I select Daylight Factor, it basically creates the components, adopt the components based on the inputs and outputs that recipe needs. And in this case, I already knew it needs a model, so that's why I prepared the model. Depending on recipe, you will have less or more. So let me do this just to show you what I mean. So if I select an annual daylight recipe, for example, and this is under a different project, you can see now I have more inputs because for annual daylight, not only I need the model, I need WEA. North, because its orientation will make a difference, I need a schedule for post-processing, and it has post-processing about threshold. This one doesn't. So based on the recipe, the inputs and outputs are going to change. Okay, so this one is an easy one. It only needs the model. You can filter the sensor grids if you want, and you can change the radiance parameters, but I'm not going to do that. I'll just skip everything to default for this case. So as soon as I connect here, you can see like it created a run for me with all these inputs that I have there. There is user inputs here that we talk about when we talk about parametric runs. For now, let's just keep it as simple as possible. So I have a model. This is Daylight Factor recipe, and this should be very familiar for Ladybug Tools users. It's basically a recipe, but it's just more flexible than what you get on Ladybug Tools. You have all the recipes that are available on Pollination. It also has the concept of role-based access control. So you don't have access to all the recipes. You have access to recipes for that project. And you can share it with different people, but that's a different video about like how you can use this, collaborate using these recipes on Pollination. Okay, now that we have this, let's go to the second one, which is for running this recipe. So this component called Pollinates, it accepts one or multiple runs. For now, we only have one run, so I connect it here. Multiple runs are useful when you have parametric runs or you have different options that you want to compare under the same execution, which we call a job. I can name it, so I can find it on Pollination. So it's called Daylight Factor Study for Emerald Building. What's the description? This is the mod, this is the run from the tutorial. Description. Subfolder is for managing where the files should be copied under project on Pollination. Maybe I should show you the project on Pollination. You don't have to go back and see this, but because this is the first one, it's probably helpful. So this is the project on Pollination, the Ladybug Tools / Emerald Building. How do I know? Here, Ladybug Tools Emerald Building. That's where I selected a recipe from. You can see there's no files here. So if I run this as is, it will copy the model right here to the root of the files, my folder structure. If I want to change this, if for example I want to separate it and put it under a folder called model, and I can do it like this, or maybe like these are the inputs for daylight factor study. I can add a subfolder for that. Let me do it. So I call this daylight. So all the files are shared inside a project for all the recipes that you run. You can think about it like a local folder that you have for a project on your machine. You can also add keywords, which will be helpful to search later on if you want to find a run from all the runs that you have. For now, just leave it as is, and then with this, it's ready to be executed. So I just press pollinate, and it starts running, selecting it, and once it's created, it will be reset to default. This means there is a job that's already submitted, and because it's designed to be async, it doesn't block my Grasshopper interface, right? So I can keep working here while the job is running. So let me go back and show it. Go back to the same page. Go now to jobs, and if I refresh, there should be a new job running here. You see it's already started, it's running. It's a fairly large model, so it takes a couple of minutes to run. These are all this here, but as I said, you don't have to come here really to check. You can stay inside Grasshopper, and there's a component here called check job status that checks the job status. So I can connect it here, and you can see it's running for 48 seconds, 50 seconds. This job should take around 6-7 minutes to run with the input values that we have for daylight factor studies. This gives me a little bit of time to show some stuff here, and then I'll pause the video and come back. So one of the things is, while the job is running like this, I can right click here and check this job on Pollination Cloud while this is running. This is basically the same as I went there and found a project, but sometimes can be really confusing, especially if you have so many projects. So it's just an easy way to go there. When you go here, from the web UI, there are a couple of things that you can see now and ever, when you come back to this page. So you can go and check the model and see the inputs. This is useful when you come back to this project later on. We'll do another video of how to load this locally to Grasshopper if you want. There is a tab here. If you go back to the run, if I click on run, while the job is getting executed, or this run getting executed, you can debug the run and see different steps. So this is, for some reason, it's still stuck in creating the octree. But once the octree is created, it will start scaling the job. The other thing that I want to talk about is, you probably think, okay, where did I set up how many CPUs should this execution use, right? You didn't set it up. You never asked. It never asked for, oh, okay, now you see our UI needs some love here, but now it's just scaled up after creating the octree to run all these different machines in parallel. So it will be running by itself, but going back to the question, you're thinking, okay, where did I say how many CPUs should this one use? You don't have to. That's the beauty of the whole way of how the recipes work. Basically, a recipe is designed to use as many resources as available, as much as resources as available for running a task, and parallelize it as much as it can. And this is for example, in this case, it's based on how do you break the sensor grids, how do you make them into smaller ones, and each sensor grid will run in parallel on Pollination while it's executing the run. Again, going back here, you will see this you see all this different dots. Every single of them is for one of those sensor grids that we had in the model. Let me go here. So every grid gets splitted, and then it tries to run the studies. Because these grids are the smaller ones, if you get a large one, it should be, yep, here we go. So this one is split in two. And this number was one of the inputs that we didn't put in here. Sensor count by default is 200. I probably should have set it to 500, which is a better default, but yep. Let's see how it goes. So I'm going to pause this this one and then come back to it once it's done. Okay, so the job is now completed. I can see it here. I can also see it on the web interface. It took more than 5 minutes, 28 seconds, 5.5 minutes for a large model. Now I can go actually and see the clean execution. of all the steps. It's a big one, so it's using around 270 different machines for running this one. And again, it's not always the best if you have more machines, because like there's an overhead when to start each run. So there is a point that like distributing the task like so many doesn't make that much sense. So that's why I said like maybe 500 was a better option for all this, for this model, which is a very large model. So now you can see all these parallel runs that has been executed after the octree was created here on the top, and these guys are post-processing. They should come down here. But as I said, our UI needs a little bit of love. But yeah, the overall workflow totally works. So it just ran, executed all the inputs, outputs, and now you can see the results are available here. I can click here and see all the results. This is different results for all those rooms. But we don't want to see it like this, right? We don't want technically to leave a Grasshopper. We just did it because this is a video tutorial. So how do you do that? So once the run is done, you can use the rest of the components that we have to bring down the results and visualize them. So there is a component here called check run results. And keep in mind, based on the recipe that you have, the results will be different. So if I connect this run, it basically knows what was the recipe, and based on that, it has only one output called results, which is a folder. When you see this star here, it means like this needs to be downloaded. And if you hover your mouse, you can see it has a description that comes from the recipe. It looks like a standard native Grasshopper component. So it has description, inputs, they have type, and all those stuff that you need to have. Okay, so let me just get this result and visualize it. Again, because it has a star, it means it's a file or folder, so I have to download it. I can download it like wherever I want, or I can be clean and say download it to Ladybug demo. If you don't, it will just create a temp folder for this. Here we go, done. The results are downloaded. Now, there is a little bit of magic here, so you don't get the files, you get the result that you want, but I'm not going to talk about that magic. It just works. You just take it as it works, and it's great. So now I have results here. You can see I have like results for all the grids. If you're a Ladybug Tools user, you already know what you need to do. You need the mesh, and you need the result to color them. I didn't want to spend time to build this. I just have this. This is again like a typical Ladybug Tools workflow. So if you don't know how this thing works, just watch one other tutorials of like how you prepare that. But I'm going to connect the results here. I flatten them because I'm going to join the mesh too, and I want everything to get a single legend. And here's the mesh. Oops. And I'm going to say, go here. Blah. This is your first simulation on Pollination Cloud. All the visualization stuff I have done here, like everything, again, like is a standard Grasshopper stuff. So you have full flexibility of preparing your model, do all the result visualization, make the changes that you want. As I said, we use the principles that we use for designing Ladybug tools in Pollination too. You are in control. It's about freedom and flexibility. It's about real-world complexity. Yeah, we're not going to lie to you that these things are easy years or that kind of stuff. But the overall workflow, just to review before we end this video, up to here, Ladybug tools. From here, I moved this guy here. Okay, Ladybug tools. Then you have pollination components. Take a recipe, the one that executed, the one that tracks the job status, and here downloading the results. And from here, again, goes back to Ladybug tools. So basically, it completes the way Ladybug tools executes. If you don't want to use pollination, you can just replace this with like Ladybug tools component. That makes sense. But as I said, not all the recipes that are on pollination will be available on Ladybug tools. And of course, this makes it very easy to access cloud computing for large models. One last thing, you see a cloud thing here. So this is running executed on pollination. We have the option to run this on local machine too. And this is one of the most exciting features I think that we have. But we have still to figure out some details about like permissions and how we want to make it work, and how does it work for private recipes and all those. But that's something that coming like shortly, that you will have the option to run the same recipe locally if you want. This is useful if you have like smaller models or things that are not going to really be useful to run it on cloud, and collaboration is not the pressing item, because one of the things of running on cloud is now this simulation or this run is available under this project, and actually because this project is a public project, not everyone on Pollination platform can see it. If it was a private one, only your team could see it, but everyone in your team could see it. So this is very important. And last but not least, I can go and get the result of this simulation and visualize it back and bring everything back to Rhino using Grasshopper from any other computer. And that will be the next video that I'm going to record. So bye for now, and see you in a bit.